Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome back to our course. In this lecture, we are beginning our project of building a linear regression model and using it in an Android app with Tensorflow Lite. Join me at Google Collaboratory. This is where we are going to build our linear regression model. You can find this just by going to the website collab.research.google.com. This will allow you to access an online code editor where you can code in Python. You can run Python files and you can run machine learning models and download them all online. So you don't have to download any code editor. Here, let's get started in a new Colab and in a new code cell. We are going to import the NumPy library as our first library. NumPy is a library used commonly in data science and machine learning because it has the NumPy array type, which allows for mathematical functions that are more complex than a regular Python array. Okay, we are going to create some arrays for our training data. So let's create train_x, a variable that uses the numpy.array function to instantiate a new list or array. And here let's put in some values like 25, 50, 75, 100, 125, 150, just some sample values for our training. Now you could also use real data. You don't have to use dummy data, but the simplest approach for a beginner is to try out this project with dummy data like we're doing here. Okay, so this is going to create a list of the NumPy list type, known as a NumPy array. Let's do a similar thing for train y. So x is going to be our list of the independent values, and then the y is the list of dependent values. So we are going to use numpy.array again, and let's put in here a series of random values. We want there to be some kind of linear correlation because we are using a linear regression. So we can do a bit of linear correlation here from x to y. For example, let's say that our y should be about twice the x. Okay, then we can do that. We could put in 50. That would be a direct correlation of y equals 2x. So we can add some randomness by making those values not quite double, but similar to double. Right, so here I'm going to put in 154, then let's do 199. So not quite double, but close. Okay, so 299, and then we have here 175, and we'll do approximately twice of 175, so approximately 360. Okay, so there you go. We have our independent data and our dependent data for the linear regression. Next, we are going to create a model that uses linear regression, and we'll feed it this data. So I'm going to import TensorFlow because we'll need that. And also from tensorflow.python.keras.models, I'm going to import the sequential model type. This is going to allow me to use this pre-made class, which is built by Keras, which is part of TensorFlow. And the sequential class is like a container for the layers of your model. Keras is a library very commonly used for machine learning. It initially was an independent library, but then TensorFlow actually integrated it. So Keras is now part of TensorFlow. So we are going to instantiate a new model. So I'm going to create a variable called model and instantiate an object from the sequential class. So you could also create all this from scratch, but it's much more common to use a library like Keras and Tensorflow. And these are open source, so if you want to see how the sequential class looks, then just go to the documentation for the class and you can see exactly how it was built. Now, as well, from tensorflow.python.keras.layers, I'm going to import the dense layer. A dense layer is a standard layer of densely connected neurons. It's a basic layer. So let's take the model and add to it our first layer. So we're just adding a layer to the model container. We're going to add a new dense layer. All right, then here, let's go ahead and put in some input size for the first layer, like 9. The input shape is going to be an array of 1 dimension, and we can add activation to our model. This is an activation function like ReLU. Now this is just an example of a model with a dense layer, and this is just a sample dense layer. You can use a different dense layer with a different input size and a different activation function, and you'll see that you'll get different results. Then let's add one more dense layer to the stack. This is going to be the output layer, so it will just produce 1 unit of output, and we'll have linear activation on it so that we're using linear regression. All right, so this is the final layer, so it's just going to produce 1 output. So the purpose of the model will be to learn from our X and Y data. So that way, if I give the model a new number, like, for example, 80, then the model will give me a prediction of what the Y should be for that input X, 80, and that will be based on the mathematical equation that the model put together to describe the relationship between X and Y. Okay, so we have our 2 layers, the 2 dense layers. Our next step will be to compile the model with a loss function. So that will be a loss metric, so the model knows how to calculate its accuracy at every training loop. So we're going to grab the model and call the compile function on the model. Here we're going to pass in a loss metric. For linear regression, you'll commonly see mean squared error being used as the loss metric. We can also add in an optimizer. So the optimizer is the function that's used to improve the model with each training loop, because the model begins with the first training loop, and initially its accuracy is going to be random. But then with each training loop, the model will get better and better thanks to this optimizer. A standard optimizer for a neural network is the Atom optimizer. You'll see that commonly used, so let's use that one. But just note that anytime you change any property of the model, you'll change the output and the accuracy. So you can test out your model with a different loss metric and a different optimizer function, and you'll see that you'll get slightly different results each time you change a property. You'll also just get slightly different results in general because the model always starts at a random place every time you restart training. As well, let's add in the metrics that we want to get. That is passed in as a list. We want to get mean squared error, MSE. That allows us to grab that as our result after each loop if we want to see the mean squared error at the end of each loop. Next, we are going to train the model. So to do that, we'll grab the model and call the fit function. We pass in our training data, train X and train Y. Then we pass in epochs, which is the number of loops that we want the model to take. So I could train this for 3 loops, which is very little. So the model will probably not train enough. I could train it for 30,000 loops, but that is probably too much. It will take too long, and it will likely lead to overfitting, where the model becomes way too precisely trained to my training data, and therefore it's not flexible to any new data. So you want to find a middle ground. For example, let's go around 1,000 loops. And feel free to experiment with a different number of loops. Just make sure that you restart the training from the very beginning if you want to have a set number of loops. You can try out 100 loops, 1,000 loops, 10,000 loops, and see how your accuracy is affected. Okay, so now we can run this code cell, and our model is going to be created. Our model will be fed the data, and our model will train for 1,000 loops. All right, so here we go. The training is quite fast because we have only 2 layers in the model. And as well, we're doing a linear regression on a very small amount of data. So because of those factors, our training is going to go quite quickly. If you have a lot of data, training can take a while. Great, so we finish at epoch 1,000. And you can see we finish with a loss of 17,000 and a mean squared error of the same. And you can check out where we began if you scroll to the very top. So you just have to go to the very first epoch or somewhere there. You can see that we started with a loss of 54,000, but then the loss was brought down over time. So that shows me that the model is improving over time because the loss decreases over time. The loss is another word for error, or how inaccurate the model is. Awesome. Okay, that is good enough for now. Feel free to continue training the model if you want to improve this loss. So if you want to get it down further, you can. But make sure you don't overtrain, because if you have a loss of 0, then you've likely overtrained and your model won't be flexible. You can actually already test out the model by calling model.predict and then passing it a list of values. These are referred to the testing x values. So you can actually make a variable called test x and set it to a list of values you want to test. For example, 30. Let's just try testing out 30. Then we can also wrap this in a print function to print our results. If we run this, you'll see our results. We get a value of about 26.78. Let's say we try this with a different number like 100. We can rerun, and this time we get about 86. Okay, so we know that the model is not that accurate because we're expecting something around 200 for x of 100 because we have approximately a correlation where y equals 2x. Let's train the model on 2,000 epochs and see if that increases our accuracy. So I'm going to rerun training, this time on double the epochs. And note that you can see here, every time you run training, your loss will start at a slightly random or different place because initially the model structure, the model weights and biases, which are the parts of the model's equation, they start off random each time. So that's why you get different results each time. So sometimes it can help just to run the training from scratch again, because you can get completely different results without even changing anything. And every time you do change something like the number of epochs, the amount of data, or the model structure, you'll also get different results. So this time we can see our loss has gone down to about 27. That's a lot less than 17,000. So that tells me our model trained better this time. So if I rerun my prediction, look here, now we get a result of 202, and that is a lot closer to what I expected. Because remember, we have a relationship of approximately y equals 2x. So if I try this on 10, then I get approximately 22. Okay, that tells me we have a model that is working as expected, because the data that we built has a relationship of y equals 2x approximately. So that's what I wanted my model to be able to predict. Because I didn't tell the model that y equals 2x, I just gave the model the data, and then the model had to figure that out on its own. And then I performed the test to see, did the model figure it out? And it looks like, yes, the model has figured it out after training a couple times. One time, 1,000 epochs, and then restarting with 2,000 epochs, and that proved to be a good decision. All right, coming up next, now that we have a working model, join me in our next lecture where we're going to take this model and save it, export it, and convert it so that we can actually use it in an Android app. So we're going to use Tensorflow Lite in order to save this model. Hello everyone, and welcome back to our course. In our previous lecture, we learned how to build a linear regression model, as well as how to use the model to make a prediction. In this lecture, we are going to learn how we can convert this model to a type that is compatible with Android Studio, and we'll be using the TensorFlow Lite converter to do that. So join me back in our Colab project. Make sure that you recently have run all of your cells with runtime run all, because if you want to run a new code cell using previous variables, you have to make sure that the cell has been run. If you leave the page and come back, you have to rerun the cells. And that is because the variables get reset if you leave or refresh the page. Okay, so here we are going to save our model, because once we have trained the model, it has a graph inside of it, and this graph is represented in code. So whenever you train a model, it takes the container with all the layers, and as the training occurs, the model becomes a specific set of equations. And we can save that set of equations for use later. So that way we can use a trained model in different projects. So we can take this model that we've trained on Google Colab and we can use it somewhere else, like in Android Studio. So to save the model, we'll use TensorFlow's Keras library, go into the models sublibrary and call the function save model. We want to save our model variable, and let's save it to a name called model.pbtxt. That is the extension that will be provided by the save model function. Now, if we want to actually use this model in Android Studio, we have to convert it to a TensorFlow Lite converter object. So we can create a TensorFlow Lite model object using the TensorFlow Lite converter. So I'm going to instantiate a converter by grabbing tensorflow.lite.tflite converter and using the function from Keras model, passing in our model variable as the argument. So the function will take the model in the pbtxt file, which is a Keras model, and it will convert it. And then we can grab our results. So next, we have to grab our TensorFlow Lite model object. So I'm going to create a variable called model underscore TensorFlow Lite. And to do that, we take the converter and call the convert function. Okay, so first we have to instantiate this converter with from Keras model. Then we actually have to call convert. So don't forget that step. And finally, we can save the model to a TensorFlow Lite file. So I'm going to call the open function, and let's give our model a name. We'll call it the linear regression model.tflite. So notice we have a different extension now. And we are going to write the model TensorFlow Lite file. So we are taking the TensorFlow Lite file with all of its equations and writing it from this model TensorFlow Lite. Okay, so then I'm going to run this code cell, and here we are going to grab this TensorFlow Lite file. So if you go into your files now, you can actually see this TensorFlow Lite file will appear. Just click on this folder on the left-hand side, and that will open up the files of the current project. So we have model.pbtxt. You can see a Keras model consists of assets, variables, metadata, and the saved model. We also have sample data that just comes from Google Colab. And then we have a linear regression model.tf Lite. So this is the model that we are going to use in our Android Studio app because this is a Tensorflow Lite model, which means that Tensorflow Lite has processed the model specifically for mobile. We're going to hover over the model and then click on those 3 dots on the right-hand side and then select download. That is going to allow you to save the model to your computer. So you want to save linear regression model.tf Lite, which is a TF Lite file from Blob. You can press save file and it will be in your downloads. And now we're ready to use that file in an Android Studio project or whatever kind of mobile project, because TensorFlow Lite, it supports iOS, it supports Android. You can build with Xcode, Android Studio, Flutter, and more. So join me in our next lecture where we're going to get started by building an Android application from scratch and then using this model in the application. In this lecture, we are going to learn how to take a TensorFlow Lite model and how to use it in an Android Studio app. So our first step is going to be to build an Android Studio app from scratch. So open up Android Studio and select New Project. Here, make sure you select the template of empty activity. There's lots of different templates that you can use. We just need an empty activity, and make sure you select that one instead of any of the others. Not no activity, but empty activity. Then hit next and give your application a name, such as the linear regression app. All right, so whatever you'd like, you can call it linear regression. Choose a package name and a save location. This is where the project folder will be created. The language that we're going to use is Kotlin. This is the next advancement after Java. Kotlin is going to overtake Java eventually as the primary Android app development language. There's also Java, but we're going to use Kotlin in this course. You could use Java if you'd like, but Kotlin is recommended. Next, choose a minimum SDK. You want to choose an SDK that can run on a lot of devices. We don't need any legacy Android support libraries. Once you are done with putting in the data for the project, hit finish, and that is going to launch for you Android Studio. So here we are in Android Studio, and we have our first file here, a class main activity. Currently, our project files are loading, so let's just wait for them to load. Okay, here we go. We have them loaded now. We have a manifests file containing Android manifest.xml. Double click on that to open it. This contains the basic launching schema for the app. We also have a Java folder, which might be confusing since we did select Kotlin, but that just stores the Kotlin or Java files for the project. Because we selected an empty activity, we actually do get a main activity here. You want to make sure you have main activity. If you don't have it, you can create it yourself. It's a Kotlin file, and it's created whenever you select an empty activity. If you selected no activity, then you won't actually have this. We also have some test files for testing the app. Then we have resources, this res folder, which has images as well as layout files, like the activity main XML file. You can see it actually contains the layout of the app, which you can view in code, in split, or in design mode. All right, so here is what the app looks like currently. It just says hello world. We also have some launcher images and values inside of the resources folder. There's also a Gradle scripts, which contains build information. All right, now the first thing we need to do is to add our TensorFlow Lite model to our project. So we are going to create a new folder inside of the app folder, and that will be a folder to contain our resources. So inside of app, let's build another folder instead of this res. Let's build one specifically for model resources. So I'm going to right click and create a new directory, which is a folder. Okay, then you can select the name for your directory. Let's do source, and then we can do slash followed by main. Okay, so I'm just going to create that. And if you're using a new directory, it also often wants you to use a prompt. So if you don't want to build a directory via Kotlin, you can also just do it via your Finder. So you can just right click on the file and then you can just open it inside of your File Explorer and just build the files that way. So here inside of your File Explorer, you have your project with your app. So here I have linear regression, I have the app. Then if you go into source and main, you'll see here you have Java and resources. So the resources contains the images, the layouts, the values, and then the Java actually contains your whole app activities, which currently we just have one. So we want to go into one of these. Let's just go back. We want to go into the main project container. So we have here main. And inside of main, next to Java and resources, we want to right click, create a new folder. We are going to call this one assets. And then you want to just copy your TensorFlow Lite model into this assets folder. Here I have copied my linear regression file, the linear regression model.tflite, into that assets folder. Okay, so now we are ready to start using the model inside of the project. So here inside of Android Studio, we want to open the build.gradle at the module level because you have two Gradle scripts. You want to open build.gradle at the module app level. Then in here, we want to add some code below the build types. So here we have build types. This here we have which SDK we're compiling for, our default configuration, our build types, Kotlin options, and dependencies. Okay, we want to add underneath build types a new option here called AAPT options, and we want to say no compress TF Lite. So this will make sure that our TensorFlow Lite file will not be compressed when the app APK is built. So this refers to the application programming kit. So when the app APK is created, we will not compress the TensorFlow Lite file. Otherwise, by default, it would be compressed. We also want to add a dependency to our list of dependencies, and that dependency is going to be TensorFlow Lite itself. So here I'm going to add implementation org.tensorflow TensorFlow-Lite plus. So this will grab for us the latest version of TensorFlow Lite. And you want to make sure that you include this, otherwise you cannot implement TensorFlow Lite into the project. Now at the top of your file, you now have to sync your changes because whenever you make a change to a Gradle file, your project has to sync. So hit sync now, okay, and that is all you need to do to sync the project. Hello everyone and welcome back to our course. In this lecture, we are going to build out the app layout for our application because we have to enable the user to put in input and then show them the output based on the model's results. You can check out your app layout by going to your application folder, resources, the layout folder, and then activity main.xml. This XML file was created because we built a project that has an empty activity. Right, so you can hide the project folder at any time, and you can check out the design view of the app. So here we have the two modes of the app. We have regular and then wireframe. Now you can edit your application layout either via design only, so you can actually make changes right here. You can go into the attributes tab and make edits to your content. You can also do it via code, via XML. So it's up to you how you prefer to design. Often you'll start with using the design mode and then go into the code mode for extra format here and putting in finer details. Okay, so at any point you can hide these attributes. Then on the left-hand side in the palette is where you can search for elements. You have common, text, buttons, widgets, layouts, containers, helpers, Google, and legacy. Okay, so let's go ahead and get started. We first need to put in a layout to actually store all of the elements. Then we need some kind of edit text so that the user can input text. Then we need to put in a text view so we can show the user their results. And finally, we need a button so that the user can actually trigger the model to start running. Okay, so we can do that via XML really quickly. Currently in our XML, we have the XML version. Then we have a layout, which is a constraint layout. That's a good layout type because it's going to implement responsivity and making sure that your objects don't get all misplaced on different screen sizes. You have a bunch of information about the constraint layout as well, like the layout width and the layout height. You also have a text view, and you can actually change the text view and its properties if you want. You can change the width, the height, the text, constraint bottom, constraint left, constraint right, constraint top. For example, you can change the text value here to be a different string that says model results. Then if you go to design view, you'll actually see that the text will have changed. It now says model results instead of hello world. Okay, and that's because we made a change inside of our code and it was directly affecting the layout. Okay, let's go back to the code and put in an edit text. That's going to be above the text view. So just open up an alligator bracket for a new element, and then it's called edit text. You can use the tab key to quickly fill in some of the basic properties for this element, like the layout width. You can do wrap content, which means it will just be the same width as its content. You can do the same thing for the height. Then you can close the edit text with the closing tag there. You may get a red underline that says that we are missing a constraint. So that just means we have to add to whom are we constraining to. Because if you have a constraint layout, your objects have to be constrained, which is what these blue squiggly lines are. Because currently we just have this text, edit text right here, and it automatically gets placed to the top left without any constraints, but we have to give constraints to it if we're using a constraint layout. So let's put in app layout constraint. We'll do start to start of, and let's do that to the parent. So this means that the start of the edit text will be constrained to the start of its parent, which is just the container. Then let's also add a layout constraint top to the top of its parent. So you can see in the design how that will affect your view. Now it's currently in the exact same spot, but now it actually has blue arrows around it because it's now constrained to its parent. All right, next we want to put in a hint or a placeholder text for this edit text. So let's add in here Android hint, and we'll put in enter and input for value. In your design, you'll now see the text view will contain enter and input value. And in your design view, feel free to drag it around and put it wherever you'd like. Okay, so there it is, enter and input value. And same for model results, you can move that around as well. Okay, and you can also change their text size either via the code or via the attributes tab. Okay, the attributes tab means that you're editing the element via the design view, and that will actually be translated into code. So I can go into text appearance and I can change the text size from 14 to 24. you'll see the text will become a lot bigger in the design view. There it is. And inside of my code, my text view now has a new property, text size. Okay, and I can do the same thing for my input value. I can open the attributes tab and change the text size to another value like 24. Okay, then you'll see the prompt will be increased in size. Okay, so you can edit in both ways, the code or the design view. All right, one more thing that we want to add to this edit text. We need to put in an ID, so that way we can reference this edit text in Kotlin code. So I'm going to add an Android ID. Okay, and let's give it an ID of edit text. Make sure that you put the ID into quotation marks. All right, there we go, double quotation marks. That way it is in the proper format. Awesome. Okay, so there we go. Now we have an edit text and a text view. For this text view, I also want to give it an ID, so that way we can reference it with Kotlin and we can replace its content dynamically via code. So I'm going to assign an Android ID, and I'm going to add an @ID of text view. Now these are quite basic IDs. You can make them more descriptive, such as input value edit text, okay, or model results text view. Okay, that's usually better because it's a lot more clear as to what you're referencing. One more thing I want to add in is a button. So again, you can do that via design or code. Let's put that in between our existing elements. You can open up a new button element and use tab to quickly fill in some of the properties, like the width and height can be wrapped. That means the width and height of the element will be the same size as whatever content is inside. Then we can use the same constraints for the button that we used for the edit text. Just some simple constraints because design is not that important right now. In our design view, we can drag around the button to place it wherever we'd like. By default, the button just looks like this purple rectangle. I want to give this button an ID, so let's set its ID property to @ID/predict button. Then I want to give this button text, so that way the user knows what they're pressing. So I'm going to set the text property to make prediction. In my design view, I can see my button now says make prediction. And again, you can increase the text size of the button via design or via code. Hit enter to see the change appear. All right, so that is the app currently. We have here an input field, enter an input value where the user can put in an input value. We have a button that they'll press, and when the button is pressed, we're going to show the results from the model. All right, so now that we have our app layout set up, join me coming up in our next lecture. We're going to get started with putting to use our machine learning model, and we're going to do that via Kotlin code. So we'll have to load in our model and then put it to use via Kotlin. Join me in the next section. Hello everyone, and welcome back to our course. In this lecture, we are going to get started with using our model with Kotlin. So join me inside of your main activity Kotlin file. Here we're going to get started by loading our model file. Currently, by default in the main activity, we just have an onCreate function, which is called when the app is created. And we are going to build another function that is going to load our model file from our assets folder. So inside of the main activity class, which was created because we built a project with the empty activity template, we're going to create a private function called load model. And this is going to be returning a mapped byte buffer. Let's use curly brackets to open up the function body. First, we need to open up a file descriptor, which is the file. So I'm going to create a value called file descriptor, and I'm going to assign it equal this.assets.openfd of the linear regression model.tf Lite file. So that is that model that we created and that we added. This.assets is going to refer to our assets folder. Next, we need to be able to read the contents of the file. So we need to grab an input stream. So I'm going to create a value called input stream and use the file input stream class. You can use the tab to quickly import this class into this file, and it will appear at the top of the file. We need to pass into a file input stream our file descriptor property. Then we need to grab the input streams channel. So I'm going to create a value file channel and use input stream.channel. We need to get the starting point and the ending point for reading the file. So I'll have a value called start, and I'm going to grab the file descriptor.start offset. Then I'm going to have a value called end, and I'm going to grab the file descriptor.declared length property. Finally, I can return my mapped byte buffer by grabbing my file channel and mapping the file channel map mode, which is read only, and going from the start to the end. You may get an unresolved reference file channel, so just hover over that and hit import. That will add the file channel to the top of your file as an import along with what we already have imported. All right, so here we have our load model. Now, we can also specify that it's going to throw an exception if something has gone wrong. So let's just import the IO exception type. Okay, awesome. Now just make sure if you get an error message that TF Lite is a typo, just ignore that. So this is how we can load a model, how you load a Tensorflow Lite model into a mapped byte buffer. So we have a bunch of bytes, which is data, a buffer, which is just a stream of that data, and then it's all mapped. So we have a map of the bytes. All right, so that is how you can load the model. What we also need to do is we need to set up all of our layout files. So remember we had activity main. So we actually need to connect all these elements in Kotlin. We need to be able to register when the user puts in an input value and when they press the button. So that way we can then make a model prediction. So we also need a function to actually do the model prediction as well. So join me in our next lecture where we are going to build the function that is going to build the model prediction. So it'll actually use the model when we need to use it. I will see you in the next lecture. In this lecture, we are going to build a function that can actually use our machine learning model in Kotlin. So join me inside of mainActivity.Kotlin. I'm going to build a private function called useModel. And this is going to take in some kind of string. So this will be the input X as a string. The reason that we're taking in a string is because the app user is going to type in some value for X, like 5. And then we have to take that string because they're typing text. We have to convert it to a number type. And then we have to send that number to the model. And the model will send back its predicted Y. So the model will return a float, which can contain decimal places. A float is a number type that can have decimals. All right, so we are going to here grab TensorFlow Lite, which is going to refer to an interpreter that can interpret a TensorFlow Lite model. So at the top of my file here, at the top of the class, inside of the class, I want to create a variable that is a global class variable called tf_lite, and it's going to be of the interpreter type, initially null. Then we're going to instantiate that TensorFlow Lite inside of the onCreate function. So here inside of onCreate, this is going to be run when the app is created. And inside of here, I want to instantiate my TensorFlow Lite interpreter. So I'm going to try to set TensorFlow Lite to equal an interpreter object. And we're going to be using our load model function for that, which returns a mapped byte buffer. And that is how we can actually store TensorFlow Lite's interpreter. If there's some kind of exception, we can catch it and we can print the stack trace. So if there's some kind of problem, we'll print out what went wrong. Okay, so now we can use TensorFlow Lite, the variable, inside of use model. All right, so there we go. We have use model. We want to take TensorFlow Lite and we want to force that it has a value, and then it actually has a run function that takes in an input and an output. So here, let's pass in input and output. All right, let's create input and output. We'll start with input. We'll have a float array of type 1. So an array is a list, so we're just creating a list of numbers that is only one value long. We need a list because that is what the interpreter expects. It expects a list, even if you have just one value. So how do we actually get our input? Well, we're going to set the input at index 0, which means the first item. We're going to set it to be our input x, which was a string converted to a float. So we can use the toFloat function to convert a string to a float. And that will be our input. So next we have to do output. To instantiate an output, we're going to build a regular array of type 1, and then we are going to pass in a floating array of length 1. So we have an array of size 1 and then a float array of size 1 in there. Okay, that will be the output. So that is how you can take TensorFlow Lite and run by passing in an input and an expected output. Then we can return our results, which will be the output at index 0 and then at index 0. So the output is actually a two-dimensional array. It's an array of an array. So the regular array is a container that has a float array. So that's why we have to go to the first array and then the first element in that array. And this is just what TensorFlow Lite expects. So we have to follow this format for input and output. And that is how we can use a model. So the model will take in x and it will return y. So now that we have functions built to load the model and to use the model, let's actually use the model. So coming up next, we're going to take all of these elements in our app and we're going to connect them via Kotlin. So we'll be able to take the user's input, listen for when they click the button, and then show them the results in the model results element here. So we're going to connect the layout with the code. Join me in the next lecture. In this lecture, we are going to connect the app layout elements with our model. Join me in mainActivity.kt. Inside of onCreate, we are going to grab the elements of the layout and connect them to our model. So inside of this onCreate function, I am going to grab my edit text, my text view, and my button. I'll create a variable called input, which is going to be from my edit text. I'll grab a variable output, which will be my text view. And I'll grab a variable called my prediction button, which will be of type button. And initially, these are all null. If you see the elements in red, just import them by hovering over them and pressing import. Okay, now how do we actually assign values to these three variables? Well, we can actually find all the elements by their ID. So after the layout has been loaded, we can grab the input element by using the function findViewById and using r.id and then a name of the ID that we used for input. So if you don't remember what we used, then just go back to activity_main.xml, open up code view, and then go to this ID, and you can see the name we used for the ID. That is the same name that you want to use for here finding the input by its ID. We want to do the same thing for output. We want to call findViewById with r.id, and then we want to grab the ID that we used for the text view, which was the model results text view. And one more, we had our prediction button. That's going to equal findViewById r.id.predict button. Okay, so we've now instantiated those three variables. Great, so what we want to do is we want to take whatever is inside of the input when the button is pressed, and we want to show the model's results in output. So after the model has been loaded with our load model function, we are going to grab the prediction button and add to it an on-click listener with the function setOnClickListener. Here we'll pass in a view.onClickListener, and we can put inside of the listener any code that we want to run when the button is pressed. When the button is pressed, I want to get a prediction, so we'll do predicted y from the model. So I'm going to call useModel, and I need to take in my input text and convert it to a string. So I'll use input.getText.toString. Because by default, an input has the text type, and you need to pass that as a string to our model. And then we can grab our output, and we can set its text property with the function setText. Here we'll pass in java.language.float.toString and pass in our predicted y. So this is just taking the float and forcing it to a string type. Okay, now this is not the only way to set a float to a string, but it's just a common way to convert a float to a string. And that is all that you need in order to use the model in the layout. So now we can press run and we can test out the app. So at the top of our file here, you can press the big green run button, and that will launch the Android emulator. So this is emulating an Android device. Here the application is loading, and then we can test it out. If you get any error messages, they're going to appear down here in the build output. Okay, for example, you might get 30 is incompatible with the attribute text size dimension. So let's see, sometimes our text sizes are incompatible, so we can just remove them or replace them. I'll just remove them for quick fix. Then you can just rerun the app. So if you at any point run into any problems with the build, just go to the bottom here into the build results, and you should see launch succeeded, and you can pop open the emulator, which is actually its own application. Here we can now see our app, and we can put in an input value here such as 44. Then if I hit make prediction, I can see my result 89. And I know that my model is working as expected because I know that I should get a relationship where y equals about 2x. We can try again with a different value like 2, and if I hit make prediction, you can see I get a result of about 5. Awesome, so that tells me our model is working in the app. So congratulations everyone, that is how you can put to use a model from TensorFlow built with Python, and you can put it to use inside of an Android app or any other app thanks to Tensorflow Lite. I will see you next time.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.